Okay, we're looking at mixed exercise 7 from the first year core textbook. So we're on question 24. So first thing we're asked to do is prove that the difference, so you always need to read these really carefully because there's lots of subtle differences in what they talk about. So difference of the squares of two consecutive even numbers. Okay, so generally an even number is 2n, 2m, whatever letter you want to use. If I just needed to talk about another even number, I would just use a different letter, okay? But they've been a bit more specific than that. They have said two consecutive even numbers. So if my first number is 2n, the next even number will be 2 more than that. I could go 2n minus 2. So I think they're probably the main two options you'd go for, okay? So, and then what are we doing? We're doing the difference of the squares. So I'm going to do, so obviously difference, you'll do one, take away another to find the difference between two things. And I'll do the 2n plus 2 squared minus the 2n squared, because obviously this will be the bigger number and this will be the number before it. Make sure you do use brackets here. This is a proof. So if you didn't put brackets there, even if you ended up with 4n squared, technically your proof isn't totally correct. So 2n minus 2 all squared is going to be 4n squared plus 8n plus 4. Don't forget that means 2n plus 2 times 2n plus 2. And then 2n all squared is going to be 4n squared. So the 4n squared minus the 4n squared is going to cancel. And we are trying to show that that is always divisible by 4. So whenever they ask you to show that something is divisible by whatever, take that out as a common factor. And yeah, I think we've shown it. So again, I know it's dull, but let's just write the conclusion. So the difference of the squares, I'll pull this bit, two squares of two consecutive even numbers is divisible by 4. So you can try and write it a little bit neater than this. Okay, right, so then, now this I think would be a lot nicer if this was an exam question, because for part B, it would be good to know how many marks that's worth. Because is it just a case, so it says is this statement true for odd numbers? So if this was only 1 mark, I would probably be thinking, oh, I'll just find an example of it not working and we'll show that it's not true. If it was worth a few more marks, I'd be thinking algebraically. So, and it's not, I don't think it's the easiest to kind of think through in your head. So without that information, I think I'll, rather than faff around and try and find, check numbers, I think I'll just go algebraically as well. So, so an odd number, generally we talk about 2n plus 1. So for the next odd number, I could go 2n plus 3, and that's absolutely fine. Or I could go for the odd number before. So if I do that, actually, that would be the order going from small to bigger. But 2n plus 1, 2n plus 3 would be absolutely fine. Okay, so it will be 2n plus 1 all squared minus 2n minus 1 all squared. So 4n squared plus 4n plus 1. And then, yeah, just be really careful with the minus here. So I'll keep some brackets, because obviously that minus means I'm going to subtract everything in that second set of brackets. So I've got 4n squared minus 4n squared is going. I've got 4n minus 4n, and I've got 1 minus 1. And then obviously I can, so I mean, so there you're going to get a multiple of 8, or it's always divisible by 8, but they are talking about it being divisible by 4. So that's not normally a factorization I would do, but that's the quickest way to show it's divisible by 4. And then if I was doing this in the exam, I would write that sentence out again, but for odd numbers. But I think for now we'll just leave it at that. And we'll just check that they did be in the same yet. So they did be the same way as us.